Bismillahirrahmanirrahim and Assalamu alaikum. Welcome to our YouTube channel Paper World, where we are solving past paper questions of IGCSE Physics 0625. Currently, we are solving the past paper questions of paper 2. And we've started a new topic, which is general properties of wave with light and sound. So today we are going to be doing its topic 3.1, which are general properties of waves. So let's begin with, before we start, kindly like and subscribe the channel. And if you find anything helpful in the video, kindly remember me in your prayers. So let's start with question number 1. Was a wave. Which dimensions describe the properties of the wave? Option A, P is the amplitude. P is not the amplitude, because amplitude is the maximum displacement from the mean position, right? So this is the mean position. So the amplitude would have just been this if it was P. The P नीचे भी चला जाता है, ऊपर भी, so this is not the amplitude. R represents the amplitude. It's the maximum displacement from the mean position of the particle from the mean position. ठीक है, तो P is not correct. P is the speed and Q is the wavelength. Q seems to be the wavelength and P is not the speed. Speed can't be represented by that. C, R being the amplitude and Q being the wavelength. Yes, this is the correct option. R is the amplitude and Q is the wavelength. A wavelength would have been from this to this place. And here it's from one trough to the other trough that's being completed. So yes, Q is the wavelength. So C is the correct option. Moving forward to question number 2. A student writes down some facts about two transverse waves. Wave 1 has a frequency f and a velocity v. Wave 2 has 4 times the frequency of wave 1 and is traveling at a velocity of 2v. What is the wavelength of the wave 2 in terms of f and v? Okay. V is equal to f lambda is the formula. And as they've stated that the wave 2 has 2 times the velocity, ठीक है, and 4 times the frequency of the first wave. So this is going to be 2v by 4f is equal to lambda. So this is going to be 1 over 2f is equal to lambda. ठीक है? So where is it? 1v over 2f. So D is going to be our correct option, right? Okay, question number 3. Straight wave fronts on the surface of a ripple tank approach a gap in the barrier. The diagram shows how the wavefronts change shape as they pass through the gap. What is this effect called? Okay, this is called diffraction. So A is our correct option. ठीक है? Moving on to question number 4. Two men P and Q stand close to a gap in a wall. Man P cannot see man Q, but man P can hear man Q speaking. So what is this? Which statement explains this? Question number 8. Light waves do not diffract at all because they are electromagnetic waves. No, that is not correct. Light waves have a range of frequencies, but sound waves has just one frequency. No, this is not correct. Sound waves are of higher frequency than light waves. No, this is also not correct. Sound waves diffract a lot because their wavelength is a smaller size to the width of the gap. Yes, D is correct. Diffraction इसलिए हो रही है because उनकी wavelength is smaller than to the size of the width of the gap. The diffraction is going to take place over here. So D is the correct option over here. Okay, question number 5. Which quantities relating to a wave on the surface of the water can both be measured in meters? Amplitude and frequency. Frequency is measured in hertz, so no. Amplitude is measured in meters and wavelength is measured in meters as well. So B is the correct option. Amplitude and wave speed. Wave speed is measured in meter per second, so that's not correct. Frequency and wavelength frequency is measured in hertz and wavelength in meters, so this is also not correct. B is the correct option for that. Okay. Okay, moving on to question number 6. Light diffracts when it enters a telescope. This causes the image to blur slightly. The amount of diffraction depends on the diameter of the hole through which the light enters the telescope and the wavelength of the light. Which combination for diameter and wavelength will result in a sharpest image, least blurring? Okay, now, where as far as diffraction is concerned now, so we know that it depends on the fact that what is the wavelength, ठीक and what is the size of the gap, ठीक If the size of the gap is equal to or a little bigger or little smaller than the size of the gap, तो the diffraction जो है वो is more, ठीक this is the principle, ठीक and obviously these lines have to be of the same wavelength as the waves that were coming in. I've just drawn them freehand. So this is the basic principle, ठीक so if the diameter is large, so it is very good. It will result in the sharpest image, यानी least blurring होगी, ठीक so this is correct. The diameter has to be large. ठीक and then the wavelength has to be short, ठीक then only you are going to get least blurring. And then if this happens that the diameter is large and the wavelength is small, so the diffraction जो है ना वो is going to be less, maybe just around the edges, ठीक so this is going to give you a clearer image, ठीक so B is the correct option for that. We know that there is another thing that I should tell you over here. So wanted to tell you that increase in the wavelength means increase in diffraction, okay? So we had to minimize the diffraction. So these two measures is going to minimize the diffraction, okay? These are small concepts that you should know in order to answer these questions. This is a fairly easy, straightforward topic, but you should know your concepts well in order to answer these questions. Okay, question number 7. The diagram shows a transverse wave. Which row identifies the amplitude and the wavelength of the wave? Okay, amplitude is the maximum displacement from the mean position. So P is giving us that. So P is the amplitude. And wavelength basically is the distance between two consecutive crests or troughs. So Q is not that, R is also not that, S is the wavelength. So P is the amplitude and S is the wavelength. So P is our correct option. Question number 8. The diagram shows a graph of displacement against time for 4 waves. All the graphs are drawn to the same scale. Which wave has the largest amplitude and the highest frequency? Okay. Now the largest amplitude would be the maximum displacement from the mean position. Okay? This thing. Okay? So these don't show the maximum displacement. These two are almost similar. So C and D can be eliminated. Now we just don't have to look for the largest amplitude. We have to look for highest frequency. So we know that frequency is inversely proportional to wavelength. If the wavelength is less, the frequency is going to be higher. So A is where the wavelength is very small. Like here the wavelength is just this much and here the wavelength is this much. So smaller the wavelength, larger the frequency, and larger the wavelength, smaller the frequency. We were looking for highest frequency, so this A gives us the highest frequency. Okay. Question number 9. The diagram shows a wave. What are the amplitude and wavelength of this wave? Okay, the amplitude seems to be 3 centimeters and the wavelength is 8 centimeters because amplitude is the maximum displacement from the mean position and the wavelength is the distance between two consecutive crests or troughs. So these are two consecutive crests and the distance between them is 8 centimeters. So 3 and 8 centimeter would be it. So B is the correct option. Question number 10. A drop of water from a tap falls onto the surface of some water at a constant depth. Okay. Water waves spread out on the surface of water. Which statement is correct? Okay, now the water waves are transverse waves and they are not longitudinal waves. So these options A and B are going to be eliminated just like that. Now C option states that the waves are transverse and travel at the same speed in all directions. Yes. And the waves are transverse and travel more quickly in one direction than the other. No, this is not correct. This is going to be the correct answer, which is C. Okay. Because this never happens that they move quickly in one direction than the other. Okay, so C is the correct option. Okay, 11. A transverse wave moves along a rope. The diagram shows the position of the rope in one particular time. Okay, which two label points are one wavelength apart? Okay. This W is the amplitude. Okay, these points we have to look for two consecutive troughs. There are no crests. So X, it starts from here, one wave, and it finishes at Z. So one wavelength apart are X and C. So C is our correct option. Okay? Question number 12. A wave source produces 3000 crests every minute. The wave has a speed of 300 meter per second. What is the wavelength of the wave? Okay. Now, in order to find the wavelength, we have the formula V is equal to F lambda. We have the speed of the wave, but we don't have the frequency, okay? But we do have that there are 300 crests every minute. So if there are 300 crests every minute, first of all, we have to find the frequency in, what do you say, seconds, okay? So F is equal to I over T and frequency is equal to 3000 over 60. Okay? So 50 hertz is the frequency over here. Okay? We had to divide it by 60 because there are 60 seconds in 1 minute and the crests were given in minutes and not. So now 300 is the speed, 50 is the frequency. So 300 over 50 is going to give you an answer of 6 meters. So C is our correct option over here. Okay? Question number 13. The diagram shows plain water waves in a ripple tank passing through a gap between two barriers and spreading out. Which name is given to this effect? Now this effect you can see is diffraction. Diffraction is the when the waves pass through a small barrier or small hole, they start to curve like this. So this is called diffraction. It's not reflection, it's not refraction, and not total internal reflection. Okay, question number 14. A passing boat causes a floating object on a lake to bob up and down 18 times in 12 seconds. The wavelength of the wave created by the boat is 48 centimeters. What is the velocity of these water waves? Okay, now they've given the velocity in centimeters per second and the wavelength is also in centimeters. So we don't need to convert it into meters. Okay? We will use the formula V is equal to F lambda for this. And we have the lambda over here, but we don't have the frequency. But they've given us the fact that it goes up and down 18 times in 12 seconds. So frequency is equal to I over T and 18 over 12. This is going to give us an answer of 1.5 hertz and velocity is 1.5 into 48. So this is going to give us an answer of 72 centimeter per second. So B is our correct option for this. ठीक हो क्या जी? Wave fronts are incident on a boundary. what is needed for the waves to refract at the boundary? Now refraction happens when there is a change of speed um, and a change of, what you say, the density of the medium. You can say, ठीक है ना? Uh, if the wave travels from shallow to deep water, or it's the other way around as well, it travels from deep to shallow water, then the refraction happens. ठीक है? Change of the speed happens because of the change of the depth of the medium. ठीक है? So for refraction, we don't need a shiny surface on the boundary. It is needed for reflection. A small gap in the boundary is needed for diffraction. So see different mediums either side of the boundary in which the frequency of the wave is different. Whenever there is refraction, the frequency of the wave does not change. The speed changes, the wavelength changes, but the frequency of the wave does not change in refraction. So different mediums either side of the boundary in which the speed of the wave is different. Yes, C is the correct option, because in shallow water the speed is slow, and in deep water the speed is fast. ठीक है? So when there is a change of speed of the medium, of then only the refraction can occur. Okay, so D is the correct option. 16. The diagram shows a wave. Which row is correct? Amplitude of the wave and wavelength of the wave. Okay, amplitude is going to be, this is a displacement time graph, and amplitude basically is the maximum displacement from the mean position. So this is 1, and the wavelength is the basically distance between two consecutive crusts or troughs, sorry, crests or troughs. So this is going to be 2 and this is going to be 10. So 10 minus 2 is 8. Again, you can also do it with these crests, oh sorry, troughs. So 12 minus 4 is also 8. So 8 is the wavelength and 1 is the amplitude. So B is going to be our correct option. Question number 17. The water wave shown has a frequency of 4 Hertz. What is the speed of the wave? Okay. Now they've given us the wavelength of 1, 2 and 3 waves. Okay, because the wavelength is the distance between two consecutive crests or troughs. So this is one wave, this is two wave, and this is the third wave. So basically the wavelength would be 36 divided by 3, because we just need the dimensions of one wave. Okay, so wavelength is equal to 12 centimeters. ठीक हो क्या? And we have the frequency as well. The speed of the wave can be found simply by using the formula V is equal to F lambda, where F is equal to 4 and this is 12. So this is going to be 48 centimeters per second. So C is the correct option. ठीक है? Be careful of this line. They've not given you the wavelength of one wave. They've given you the wavelength of 3 waves. So be careful over here. ठीक है? Question number 18. A sound wave is created by a loudspeaker that vibrates backward and forward 96,000 times per minute. The speed of the sound is 320 meters per second. What is the wavelength of the sound? Okay, again we have to use the formula V is equal to F lambda. We have the speed, but we don't have the frequency, but we have it that it's 96,000 times per minute. So F is equal to 1 over T. So F is equal to 96,000 and this is per minute. So it has to be converted into seconds. So this is going to be it. So the frequency is going to 1600 Hertz. So this is going to be 320 over 1600 is equal to lambda. So this is going to give us an answer of 0.2 meters. Okay, so A is going to be our correct option. Okay, moving forward to question number 19. Length of the beam of X-ray traveling through air is 5.4 into 10 raised to the power minus 9 meters. What is its frequency? Okay, now V is equal to F lambda. We know that all the waves in the electromagnetic spectrum have a speed of 3 into 10 raised to the power 8. A visible light has the same speed, radio waves have the same speed, ultraviolet light rays have the same speed, microwaves have the same speed, gamma rays have the same speed. So all the rays that are included in electromagnetic spectrum have the same speed. Okay? So we are going to write this over here if it's not given to us in the statement. Okay? And the wavelength is 5.4 into 10 raised to the power minus 10. So this is going to give us an answer of 5.6 into 10 raised to the power 17 hertz, which is our option C. Okay, moving on. Question number 20. A tank contains water. Ripples are produced on the surface of the water. Refraction is observed. What causes the ripple to refract? I've just told you that the refraction occurs when there is a change in speed of the wave, and that happens because of the difference in the depth of the water. If the water moves from shallow to deep or from deep to shallow, and there is a change in the speed, okay, of the wave. So option A is the cold water in the tank is replaced by hot water. No, it's not related to the temperature. The ripples change speed as they move from deep to shallow water. Yes, this is what I just told you. So B is the correct option. The ripple hit the wall of the tank, फिर reflection होगी, refraction नहीं होगी. The ripples pass through a narrow gap. It's going to be diffraction and not refraction. ठीक है, तो B is the only correct option over here. Okay, question number 21. The diagram shows wavefronts of water passing through a gap in a barrier. Which change will increase diffraction of wave as it passes through the gap? Okay, now if the gap is reduced, so it will lead to more diffraction. Okay? If the size of the gap is equal to the size of the wavelength of the wave, so the diffraction happens or occurs more. Okay? So just go through the options. Increase in the amplitude of the wave? No. Increase in the width of the gap? This is going to reduce diffraction. Okay? If the gap increases, the waves are going to spread out more, and we need them to spread out less. So this is also not it. Reduce the depth and reduce the frequency of the wave. So reduce the depth of the water. Shallow and that deep water is for refraction and not for diffraction. Reduce the frequency of the wave. Yes, this is the correct option because frequency and wavelength are opposite to each other. So if you will increase the frequency, so the wavelength is going to increase, and if you are going to reduce the frequency, the wavelength of the wave is going to increase. And if the wavelength is going to increase and be of the same size as that of the gap, so the diffraction of the wave is going to increase. So D is the correct option over here. ठीक हो गया? To which row is not correct for a wave on surface of the water? Quantity. Amplitude is measured in meters, yes. Frequency is measured in hertz, yes. Wavelength is measured in meters. This is the symbol for wavelength, not its unit. So C is not correct. Speed is measured in meter per seconds. Okay. Question number 23. The diagram shows the pattern of water waves as they pass through a narrow gap. Which row names the process shown and describe the effect using a wider gap? Okay. This is diffraction, and if the gap is wider, so the waves spread out less. So wider gap, the waves spread out less, and diffraction. So C is going to be the correct option for this. Okay. Question number 24. The diagram shows waves in a ripple tank containing water. The waves approach a barrier and pass through the gap in the barrier. The size of the gap is about the size of the wavelength of the ripples. The gap size is increased. What happens to the ripple pattern to the right of the barrier? If the gap size is increased, so what happens is that the waves spread out less. Okay? So the ripples are not going to be more curved. The ripples are less curved, and we can also say that D is our correct option because the ripples are closer together or the ripples are further apart. This does not depend on the gap. This means that the wavelength is being changed. Okay, the wavelength is not being changed. The gap is becoming wider or the gap is becoming smaller. So the wavelength is not changed. So these two won't apply over here. Okay, and the ripples are going to be less curved as the distance over here increases. So it's going to be diffraction is going to be lesser. Okay, question number 25. The diagram shows a wave. Which row correctly indicates the amplitude and the wavelength of the wave? Okay. Wavelength is the distance between 1 and 2. Yes, this is correct. And the wavelength is between 4 and 5. No, this is not correct. So this is not the correct option. It is the distance between 4 and 6. So amplitude is the distance between 1 and 2 and the wavelength is the distance between 4 and 6. So B is our correct option. ठीक हो गया? Question number 26. Two beams of light are both the same color of red. One beam is traveling through air, the other beam is traveling through water. Each beam has a different brightness. Which quantity is the same for both set of waves? If the both set of waves are made up of the same color, so they would be having the same frequency. ठीक है? B. The speed can't be the same because one is traveling through air and the one is traveling through water. So the speed in air is more than that in water and more than that in solid. Solid में तो खैर वो गुजरेगी नहीं, but anyways this is the thing that is with the speed can't be the same. Amplitude is going to be different because the speeds are different, ठीक है, and wavelength is going to be different as well. So frequency is one thing that will be the same because they are of the same color. ठीक है? Question number 27. In the diagram, the mountaineer can hear the stream although he cannot see it. When he is closer to the gully, he can both hear and see the stream. When he is further away from the gully, he can neither hear nor see the stream. Which statement is not correct? Okay. As he approaches the gully edge, he hears first the short wavelength, higher frequencies, and then the long wavelength, lower frequencies. Okay. Let's look at the other options and then I'll explain. B, as he approaches the gully edge, the sound becomes louder. Yes, this is correct. Sound becomes louder because the loudness of the sound depend upon the amplitude. Okay. So now you can hear this loud and clear. So this is correct. So this can't be our option. He hears the stream because of the sound is diffracted. Yes, sound bends around the edges and that is why we can hear that. Okay, so this option is correct as well. He hears the stream because some of the sound is reflected from the opposite wall of the gully. This is exactly correct because in this kind of a situation, when there is rocks and rocky stuff around, so there is going to be an echo. So sound is reflected and he can hear it. So this is also correct. I mean, this is correct. So the only thing which is not correct is A, because he can't hear the short wavelengths and higher frequencies and all this. This is not going to change, na? So that is why A is not correct. Question number 28. Sometimes elimination is the best technique. You knew that B, C and D are correct, so A is going to be not correct. And whatever it's saying is totally confusing. Question number 28. Which row correctly defines the frequency and the speed of the wave? Frequency is not just the number of the waves, it is number of waves per unit time. Frequency is this. ठीक है ना? So it is the number of waves per unit time. So these have to be eliminated. Speed is equal to distance over time. ठीक है? तो speed is the distance traveled per unit time. So C is the correct option. Time taken for one complete wave to pass a point is not speed. Okay. टाइम पीरियड. सो 28 का आंसर सी है. Moving on to question number 29. A water wave passes into a region where the water travels more slowly. As it passes into slow region, what happens to the frequency and what happens to the wavelength of the wave? Okay, the phenomena that we are talking about over here is refraction. ठीक है? Whenever the refraction occurs, we know that V is equal to F lambda. ठीक है? And okay. Question number 29. A water wave passes into a region where water travels more slowly. As it passes into the slow region, what happens to the frequency and what happens to the wavelength of the wave? Okay, the phenomena we are talking about over here is refraction. Okay, and you should know that what are the properties you can say, or what are the instances that happen in reflection, refraction, and diffraction. Okay, we should remember and know that the frequency of the wave does not change in reflection, diffraction or refraction. ठीक है? In the phenomena that we are talking about, refraction, over here the speed changes, and because of the change in speed, the wavelength changes as well. ठीक है? When the wave passes from a shallow to a deep region or from a deep to a shallow region, so its wavelength changes and speed changes. ठीक है? The frequency has to remain the same in the reflection, the diffraction and refraction. ठीक है? The wavelength basically when we are, as it passes into a slow region, so it was in a deeper region and then it has gone to a slow region. So we know that the speed in the deep region was more and the speed in the shallow region becomes less. So now the wavelength obviously is going to become less as well. So the wavelength basically decreases. Okay. Moving forward, question number 30. A beam of light is monochromatic. What does monochromatic means? I told you before as well, mono means one and chroma means color. So it means light of one color. So if there is a light of one color, so all the waves in the beams must have the same frequency. Yes, the frequency is going to be the same. They won't have the same amplitude. All the waves in the beam must have the same speed. ये भी is not necessary. All the waves in the beam must have the no. Three things, all three things are not the same. जैसे we did a question above that there were two beams that were of the same red color. One was passing in the air and one was passing in the water. So they had the same frequencies. The speeds can be different. The amplitudes can be different, but the frequency is going to remain the same. ठीक है? I did explain everything in the first question, so this must be enough. ठीक है? 31. What is the approximate wavelength in air of the highest frequency sound that can be heard by a normal healthy person? Okay, a normal healthy person can hear a sound ranging from 20 hertz to 20,000 hertz. So it says that the sound of the highest frequency, though we are going to use the value of 20,000. And it's the wavelength in air. Though we know that the speed of sound basically in air is 330 to 340 meter per second. Then it's in 1500 in liquids and almost 5000 in solids. So we can use a value of 340 over here. Okay. So V is equal to F lambda. We can use 340 is equal to this. We have to use the highest one, so 20,000 in lambda. So 340 over 20,000 is going to give us 0.02 meters as our wavelength, which is A. Okay. The answer is 0.017, or if you use 330, so it would be 0.016. So you have to round it off to 0.02. Okay. So this is it. Question number 32. An optical lever is a very small sensitive device for detecting small rotations. A lamp sends a narrow beam of light to a small plane mirror attached to a shaft whose rotation is to be measured. The operation of the device is shown in plan view. The beam from the lamp reflects from the mirror to give a small spot of light on a scale placed just above the lamp. The shaft and mirror rotate 1 degrees. The spot of light moves along the scale. The table shows the angle theta through which the reflected beam rotates and the conditions required for high sensitivity. Which row is correct? Okay. So, required for high sensitivity. Okay, this is your keyword. And we are going to focus all of our answers and all of our logic on this. Okay. Now, what they are trying to tell you is that this is a lamp, and obviously, a ray of light goes to this mirror, which has been attached to a shaft. A shaft is something that can rotate either ways. Okay. So when the beam of light falls on this mirror, so the shaft starts to rotate, and as the shaft rotates, so this mirror angle of this mirror also changes. Okay. First it was attached to the shaft like this. Now when the shaft has rotated a bit, so obviously its position has changed. ठीक है, थोड़ा और rotate करेगा अगर shaft, तो उसकी position mirror की ऐसे भी हो सकती है. Now this is the position when the ray of light comes to the mirror and then gets reflected at an angle. ठीक है, this angle basically abhi is 1 degrees. Over here there was no angle, so it was reflected back, as you can see the arrows moving back and forth. Okay. Now if you've understood this thing, if you want the table to show the angle through which the reflected beam rotates and the conditions required for high sensitivity, if you want this to rotate as well, you want the beam to produce something that is high sensitivity, say. So what you need to do is that if this is an arrangement, let me make it for you. Okay, now this is the arrangement. So if you want the conditions for high sensitivity, what is going to happen is that this angle needs to be greater than 1 degree. ठीक है, थोड़ा सा angle बढ़ाएंगे तो over here the options are 2 degrees and 1 degrees. So this angle should be 2 degrees for sensitivity, and the distance between the lamp and this mirror needs to be more so that you can see this spot, the reflected spot, very clearly. ठीक है, if the distance is going to be less, like for example if this is moved over here, so you won't be able to see the spot very clearly. Okay, in order for this high sensitivity to be true, you need the distance to be more and the angle to be greater as well. So if we look at our options, so excuse me, option D is going to be our correct option for this one, where the angle is greater than 1 degrees and the lamp and the scale need to be as far from the mirror as possible so that you can detect the spot very clearly. Okay, so I hope you understood the question. For high sensitivity, the angle has to be greater and the distance has to be more as well. Okay, so always remember that. Okay, moving on to question number 33. A radio transmitter broadcasts a frequency of 200 kilohertz. What is the wavelength of these radio waves? Okay, now if you need to find the wavelength, we have the formula V is equal to F lambda. Okay, so we have the frequency, and as we know that radio waves are from the electromagnetic spectrum, and all of those waves in that spectrum have a speed of 3 into 10 raised to the power 8. So if the speed for radio waves, microwaves, infrared waves, visible light waves, and gamma rays is not given, so you can always use 3 into 10 raised to the power 8 from your own accord. Okay, ji? Sometimes this value is given as well, and sometimes it's not. So it's always a good thing that you remember this, okay, and keep that in mind. So what are we going to do is 3 into 10 raised to the power 8, and the frequency is not in hertz, it is in kilohertz. So this is going to be 200,000 hertz, okay, because the answers are in meters. 200,000 hertz and lambda. So 3 into 10 raised to the power 8 by this is going to give us an answer of 1.5 into 10 raised to the power 3 meters. ठीक हो क्या? Okay, question number 34. Which row correctly describes light waves? Wave type longitudinal, parallel to the direction of the wave travel. Yes, direction of vibration is correct. No, this one is not correct. Transverse. Um, Acha, okay, we have to describe the light wave. So this might be correct, but but light wave is a transverse wave, and its direction of vibration is perpendicular to the direction of the wave. So D is our correct answer. Question number 35. A student draws a diagram to illustrate the different sections of a longitudinal wave, which labeled section is a rarefaction. Okay. Now we can see that this is compression, okay, and basically this is a compression again. C is giving us the wavelength. So A and C can't be our options, right? And D is somewhat between a rarefaction, and B is the actual rarefaction, okay? So this is a compression, this is a compression. So wavelength is from one successive compression to the other successive compression. In between, this is rarefaction. Okay, this is a part of rarefaction. So this shows rarefaction, which is B. Question number 36. The diagram shows a part of a diffracted wave pattern. Changes are made to the wavelength and to the gap size to produce a semicircular diffracted wave pattern. Which row produces the required semicircular diffracted wave pattern? Okay, if you can see that the barrier is the hole in the barrier is way more than the wavelength of the wave. If you need to be need the waves produced to be semicircular, so what you need to do is that these two things should be equal. The whole should be equal to that of the wavelength. So either increase the wavelength, okay, or decrease the barrier. Both of them will have the same effect, okay. So you can check the answers. A gap in the barrier to make it larger. If the gap barrier is made more larger at this moment, so diffraction is going to get lower. ठीक है, semicircular आपकी हरगिज नहीं बनेंगी waves. So if the gap in the wave is the same and the wavelength is larger, made larger, so this is going to give you semicircular waves. If the wavelength is will get almost equal to the gap in the barrier, so you will see more diffraction and semicircular wave pattern. ठीक है? A water wave has a speed of 2 meter per second. 4 complete waves pass through a point every 10 seconds. What is the wavelength of the wave? Okay, to find the wavelength of the wave, we need V is equal to F lambda. So we know the speed, which is 2 meters per second. We don't know F. F is equal to 1 over T, and it is 4 waves in 10 seconds. So this is going to give us an answer of 0.4 hertz. Okay, so 0.4 lambda 2 over 0.4 is going to give you an answer of 5 meters. ठीक हो गया? Okay, question number 39. When water wave passes through a gap, they diffract. The diagram shows wavefronts approaching a narrow gap. In which diagram will the diffraction be least? Okay, इसमें तो this and this seem to be almost same, so diffraction would be high. It won't be least. Here the wavelength is more and the gap is less. Um, Here the gap is way, I think, more than the wavelength. So इसमें diffraction should be least and this seems to be the same. So I think C is the answer. Yes, C it is. Because we know, I've told you many times that the wavelength of the waves should be equal to the gap in the barrier for more diffraction to happen. ठीक है? So if either you increase the gap or you just increase the wavelength, तो the diffraction is going to reduce. यहाँ पे बहुत अच्छी waves बनेंगी इस तरह से, obviously taking care of the fact कि ये wavelength कितनी है, use your rulers for this. यहाँ पर wavelength ज़्यादा है, gap छोटा है, तो भी ऐसा होगा कि diffraction ज़्यादा ही होगी. But यहाँ पर wavelength is very less than what the gap over here is. So इसमें diffraction कम होगी. यहाँ पे the wavelength and the gap are almost the same, तो यहाँ पे भी diffraction ज़्यादा होगी. ठीक है? So C is our correct option. Question number 39. The diagram shows a wave before it reflects from a barrier. Which labeled section of the diagram represents a wavefront? Okay. So if you see that these are the waves that are being reflected, ठीक है? So this is when the waves are going in. This B represents the wavelength. The wave fronts would, this is the barrier D. The wave fronts would only be represented, wave fronts of the reflected waves would be represented by C. Okay, so this is it. Question number 40. Sound travels through air at a speed of 340 meter per second. A source generates sound waves at a frequency of 1.2 kilohertz. What is the wavelength of the sound waves? Okay, again we use our formula V is equal to F lambda, where V is 340 and the frequency is 1.2 kilohertz. This means that 1.2 into 1000 and so this is going to be 1200. Okay, and 340 over 1200 is going to give us 0.28. So A is the correct answer. ठीक हो गया जी? Okay, moving on to question number 41. A vibrating object produces ripples on the surface of a liquid. The object completes 20 vibrations every second. The spacing of ripples from one crest to another is 3 centimeters. What is the speed of the ripple? Okay, so there is a vibrating object creating ripples. The object completes 20 vibrations every second. So the frequency is 20. ठीक है, the spacing of ripples from one crest to the next is 3 centimeters, so our wavelength is equal to 3 centimeters. And if we have to find the speed, so we just have to use our formula where we multiply 20 with 3. So it's going to give us an answer of 60 centimeter per seconds, because everything over here was the wavelength was in centimeters. We didn't have to change it in meters. ठीक है, तो C is our correct option. Question number 42. Plain water waves travel from a shallow region into a deeper region. They travel more quickly in the deeper water. Which diagram shows the wave pattern in deeper water? Okay, if they are in deep water, so they are going to travel at a much greater speed. So if this was initially like this ना, तो now it would be like this a bit. If it had to go like this, if the water was like this, तो ये इस तरह हो जाएगा, ठीक है, और ऐसे. So C is the correct option for this. And if these traveling from deep to shallow water, where in the deep water their speed was more than now it is in the shallow water. So if you see, so they are going to lag behind a bit. वो पीछे रहना शुरू हो जाएंगी because their speed have reduced. But if they've entered from shallow to deep water, so their speed is going to get increased. So that is why such a pattern is going to be observed. And over here, the wavelength has changed. So D is not the answer due to that. Okay. Question number 43. A transmitter produces radio waves of wavelength 1500 meters. It takes the waves 0.025 seconds to travel from transmitter to a radio receiver. What is the distance between radio transmitter and the receiver? Okay, if you have to find the distance, so we need to use our formula. Speed is equal to distance over time. Now, we've been given wavelength, and this is just there to confuse you guys. Wavelength has nothing to do with speed, distance, and time formula. We know that radio waves are there, so they've not given us the speed. We can write it ourselves. We know that speed is equal to distance over time. The distance we have to find and time is 0.025 seconds. So when we multiply 3 into 10 raised to the power 8 with 0.025, so the answer that we get is 7.5 into 10 raised to the power 6 meters. So this is the distance. So always watch out for these. Not everything has to be used in the solving the question. Okay, sometimes it's just there to confuse you guys. Okay, question number 44. A tank causes what? A tank contains water. Ripples are produced on the surface of the water. What causes the ripples to refract? Okay, the refraction happens when you move from when you change the depth of the water. Okay, so let's go through the options. The cold water in the tank is replaced by warm water. No. The ripples change speed as they move from deep water to a shallow water. Yes, this is correct. The ripples hit the wall of the tank. This is reflection. And the ripples pass through the narrow gap. This is diffraction. Okay, so refraction occurs because of this. So B is our correct option. Moving on to question number 45. Which arrow on the graph shows the amplitude of the wave? Okay, amplitude is basically the um, maximum displacement from the mean position. ठीक है? So this is a mean position. If we look at the maximum displacement, so it would be either this or this. ठीक है? Not the whole one, either this or this. So B is going to be the amplitude of the wave. Okay. Moving forward to question number 46. The diagram represents plane wavefronts of water wave about to strike a solid barrier. Which diagram shows the position of the wavefronts after reflection from the barrier? Okay. See, these are going to come over here like this. Okay. And then either they get reflected like this, or they might reflect in the opposite direction as well. It's okay. So as the barrier is not straight, so this option A won't be the correct answer. If the barrier is straight, so the waves are going to come like this and go back like this as well. But when the barrier is slanted, so now they are not going to go like that. Okay. So as I've drawn this, so this might be the reflected waves. Okay, this can't be it. So I think C is the correct option. Okay, this is how they are going to get reflected, और फिर ये आपको ऐसे ऐसे और ऐसे नजर आएंगी, right? So moving on to question number 47, which row shows an example of a transverse wave and an example of a longitudinal wave? So transverse wave, light wave is a transverse wave. Radio wave is also a transverse wave. So no, option A is not correct. Radio wave is a transverse wave. Sound wave is a longitudinal wave. Yes. So I think B is the correct option. Transverse wave, but this is also a transverse wave. This is longitudinal wave. This is transverse wave. So B is the correct option. Question number 48. A wave passes through a gap and diffraction causes the wave to spread out. Which wave spread out the most? Okay, in order to understand diffraction and spread out of the waves due to diffraction, we need to understand 3 points. That the gap size and the spread out are inversely proportional. More the gap size, lesser the spread out. Lesser the gap, more the spread out. And the third thing is that you should always remember that increasing the wavelength means there is an increase in diffraction. Okay? So spread out is going to be more if you increase the wavelength. Okay? You've got to remember these 3 points when you are answering questions related to diffraction. You should always know these things. Okay? So if we now look at the options, large wavelength through a gap slightly larger than the wavelength. Yes, this is going to give more diffraction, and more the diffraction, more is going to be the spread out. Okay? Lesser the diffraction and lesser is going to be the spread out. So large wavelength through a gap much nahi. The wavelength and the gap size should match. Small wavelength through a gap much larger than no. The gap size should be almost equal to or a little bigger or a little smaller than the wavelength, not more than that. Small wavelength through a gap much smaller than the wavelength. No, this is not correct. So A is the correct option. Kindly remember these 3 things to answer the questions related to diffraction. And you will, inshallah, answer them correctly. Okay, a laser is a source of light with single frequency. Which description of this type of light is correct? Okay. So if there is a light of single frequency, then we know that it is going to be a monochromatic light. Okay? Question number 50. Different waves hit barriers with different sized gaps. The waves will diffract. In which diagram does the greatest spreading occur? Okay, for the greatest spreading to occur, the gap should be smaller. ठीक है? And the wavelength should be more as well. More the wavelength, more the diffraction. So now we look at this. The wavelength is 1 centimeter, the gap is 2 centimeters. The wavelength is 2 centimeters and gap is 2 centimeters. Wavelength is 1 centimeter, gap is 3 centimeters. So this seems to be the ideal gap that will cause the greatest spreading to occur. The wavelength and the gap size, when they are balanced, to the greatest diffraction occurs. Okay? Always remember this formula. ठीक है? Diffraction में the wavelength and the size of the gap, if they are equal or a little bigger or smaller than each other, so this means that the most of the diffraction is going to happen over there. अब देखो ना यहाँ पर the wavelength is 1 centimeter and the gap is double the size of the wavelength. तो इधर तो spreading is not going to be more ना. More the gap size, lesser the spreading. यहाँ पे भी it's 1 and then it's 2 times more than the wavelength. So more the gap, lesser the spreading. ठीक है? So if you want the spreading to be more, the gap should be smaller. Over here as well, it's 2 centimeters and the gap is almost 3 centimeters. Like almost double that of this. So B is going to be our correct option for that. Okay, question number 51. A person uses surfboard to ride 30th wave crest towards the beach. The wave crest travels at a speed of 1.6 meter per second and the distance between each wave crest is 24 meters. How many wave crests does the person surf in 1 hour? Okay, achha, this question requires a little more calculations than is usually required for a 1 marks question, but inshallah, I'll be teaching you that and you'll understand that as we get done with this question. अच्छा जी, तो सबसे पहले what we are going to do is we are going to calculate the time it takes for one wave crest to travel the distance between crests. ठीक है? For that we have a formula, distance is equal to speed over time. So distance is going to be 1.6 and speed we know is sorry, 1.6 is the speed and 24 is the distance. So टाइम इधर जाएगा तो 1.6 over 24 हो जाएगा. तो we are going to get the time as 15 seconds. So this is the time that it takes for 24 a wave traveling with this wavelength and this much speed. Okay. So once we are done with that, we will calculate the number of wave crests that pass the point in 1 hour. ठीक है? बेसिकली आपकी फ्रीक्वेंसी जैसे निकलती है तो नंबर ऑफ क्रेस्ट्स निकाल रहे हैं हम. टाइम हमारा होगा इन 1 hour ओवर टाइम फॉर वन क्रेस्ट. अभी हमने टाइम फॉर वन क्रेस्ट निकाला था एज यू नो टू बी 15 seconds. ठीक है जी. So we are going to put in our values. Time in 1 hour would be 3600 seconds and this is 15. So number of crests जो हमारी total बन रही हैं in this time वो बन रही हैं 240 crests. ठीक है? I'll just start doing it over here. अच्छा, once you found out कि जी number of crests कितनी बन रही हैं in 1 hour and you find the time it takes for the time period for that. तो उस वक्त आपने जब वो कर लिया तो अब आप निकालेंगे. You know that the person surfed over like 30th wave crest. ठीक है? So the number of crest that he surfed in 1 hour is going to be number of crests surfed would be equal to number of crests passing in 1 hour by obviously he was traveling at 30th wave now. So these are 240, we just found them out. Okay, 240 over 30 is going to give us 8. So the wave crests the person surfs in 1 hour is going to be 8. ठीक है? ज़्यादा calculation है, थोड़ा tricky सा question है, but it's okay. Question number 52. In a shallow tank, water moves towards a barrier with a narrow gap. Okay, which diagram shows the wave beyond the barrier? अगर अब हम देखें, वैसे you always use a ruler for this. So this and this seems to be like almost the same. So if the gap in the barrier is equal to the wavelength of the wave, so diffraction is going to be more. ठीक है? And the spreading is going to be more as well. So A जो है is not the correct answer. इसमें अगर gap इतना या मे भी इतना होता तो ऐसा होता और वो उसमें भी थोड़ा सा साइड टर्न कर देती हूँ और ये ऐसे एक जैसे नहीं होते हैं. ये भी ठीक नहीं है ऑब्वियसली. ये इसमें बिल्कुल जो क्रेस्ट हैं वो एक जैसी ही बन रही हैं जबकि क्रेस्ट जो हैं वो ऐसे शो की जाती हैं व्हेन वी शो डिफ्रैक्शन. तो डी इज द ओनली करेक्ट आंसर. ठीक है? So D is the correct answer. Moving on to question number 53. Which wave has an amplitude equal to half of its wavelength? Okay. This is a wave. Its wavelength is going to be like इस point से इस point तक between two consecutive crests या two consecutive troughs. तो 2 minus 1 इसकी wavelength is 1. ठीक है? तो अब we have to find a wave that has an amplitude equal to half of its wavelength. So if this is 1, the amplitude should have been 0.5. So over here the amplitude is 1. Amplitude basically is the maximum displacement of the particle from its mean position. So इस wave का wavelength 1 है और जो amplitude है वो भी 1 है. Both are measured in meters. So this is not a correct option. ठीक है? If we look at this wave, so now you see that this is our wavelength. ठीक है, the distance between two consecutive troughs or troughs. So 3 minus 2 is going to give us the wavelength to be 1. Now if we see the amplitude, तो amplitude उसका has to be 3 minus 1, oh sorry, 3 minus 1 is 2. Sorry, 3 minus 1, 2 होता है. तो इसका जो amplitude है, that is 1. So this is half of this. So this is going to be our correct option. ठीक है? Let's look at the other options as well. अब यहाँ पे अगर आप देखो तो इसका है almost 4. Wavelength is 4. 4 का half would have been 2. So इसकी जो amplitude है, that is hardly that is 0.5. So this is not the half of this wavelength. So इस वजह से this is not the correct option. और इसका भी 4 है तो 4 जो है उसका wavelength amplitude should have been 2 अगर उसका half लेना होता. So it is not there. तो this is also not the correct option. This is the correct option जिसके अंदर the wavelength was 2 and the amplitude was 1, which is half of the wavelength given. Okay जी. Question number 54. A man is talking at the side of the house. He can be heard by a woman at the front of the house even though she cannot see them. What is the explanation for this? Acha. Whenever we talk about this phenomena, na, that sound is being heard even though the person is not inside, so this is related to diffraction. Okay? That's basically the bending of the waves. Okay? And I have told you many times before that larger the wavelength and larger will be the diffraction. Even in the questions that are related to the water waves being created and passed through that barrier. Okay? So it's basically the bending that makes the woman hear the sound, and basically the light waves don't have this much wavelength as compared to the sound waves, so they don't bend, and that is why the woman cannot see it. Okay? So sound basically has a larger wavelength than light, visible light, or what you can see. Okay? If now we look at the options now, so we can reach our answer very easily. Sound waves are longitudinal and light waves are transverse. Sound waves are longitudinal and what do you say? Light waves are transverse, but this is not the reason for this phenomena that she is hearing the sound but is not seeing the person. ठीक है? The sound waves are transverse. ये तो वैसे ही गलत हो गया. This thing is correct, but it's not explaining the phenomena. ठीक है? The sound waves have a long wavelength and light waves have a short wavelength. Yes, this is the reason why the woman can hear the sound but cannot see the person, because sound waves larger wavelength हो रहे हैं, जब वो यहाँ से उनको barrier एक मिलता है तो they bend around it, but the sound waves do not. So that is why C is our correct option. ठीक है? All such questions point to diffraction. If you remember the rules of the diffraction, so inshallah you are going to be able to do that. Okay. Question number 55. Which diagram shows what happens when plane waves pass the edge of the object as shown? When the waves are going to pass at the edge of the object, they are going to bend. Okay? They can't go on moving straightly. Okay? So this is not the correct answer because there has been no effect. कोई change ही नहीं हुआ after they've passed uh, through the edge of an object. ठीक है? अच्छा, B, why is B not correct? Because the diffraction always is like in this direction. ठीक है? It's not like this. ठीक है? This is the, or this is the pattern for that. ठीक है? So this is why this is not correct. In C, यहाँ से waves have been eliminated, but they are going straight. No, the bending is going to be there. So that is why D is our correct option. ठीक है? Question number 56. The frequency of the wave is doubled. The speed of the wave does not change. What happens to the wavelength of the wave? Okay. We know that these three quantities are associated with each other through this formula. So now they say that the speed is not changed. The frequency is doubled. So what effect is going to this going to have on the wavelength? So wavelength is this. Okay, so if this is increased 2 times, so this is going to half. This is going to reduce this time as well. Okay, so if we look at the option, it becomes 4 times as large. No, because these are in indirect proportion. So if something is increased, the other is going to decrease. Okay, it does not change. No, it is going to have an effect. It doubles. No, it does not double. How can it double? It halves. Yes, it reduces by the factor of 2. Okay, so this is going to be it. Question number 57. Which row shows the nature of light waves, sound wave, and X-rays? Okay, light waves are transverse waves, sound waves are longitudinal waves, and X-rays are transverse waves as well. I've told you that all the waves that are present in the electromagnetic spectrum, which are radio waves, microwaves, infra, visible light, ultraviolet, X-ray, and gamma. So all of these are included in transverse wave. Okay. So basically, light is transverse, sound is longitudinal, and this is transverse as well. So C is our correct option. Okay. Okay. Question number 58. Sound wave of frequency 2 kilohertz travels through a substance at a speed of 800 meter per second. What is the wavelength of the wave? Okay. We are going to use our formula. V is equal to F lambda. Now the speed was 800 meters per second and the frequency was 2 into 10 raised to the power 3 hertz lambda. So 800 over 2 into 10 raised to the power 3 is going to give us an answer of 0.4 meters. Okay, so A is going to be our correct option. Okay. Question number 59. Which row correctly defines a type of wave and gives a correct example? Okay. Wave type is longitudinal. Direction of vibration parallel to the direction of the wave. ये ठीक है. Example is a radio wave. यहाँ ये these two are correct, but example can't be a radio because it is an example of transverse wave. ठीक है. All the waves that are present in electromagnetic spectrum that are radio waves, microwaves, infra, violet, ultraviolet, X-rays and gamma rays, all are examples of transverse waves. Okay. Option B is longitudinal. Direction of the vibration is perpendicular. Nahi ji. This is not correct because the direction of the direction of vibration in longitudinal waves is parallel. Acha, C is transverse waves parallel to the direction of the wave travel. No, this is not correct. A transverse wave, in transverse waves, the direction of vibration is perpendicular to the direction of the wave. So D is our correct option. Obviously, radio wave is an example of transverse wave. The direction of vibration of a transverse wave is perpendicular to the direction of the wave travel. So this is correct, basically. Okay, which is a unit of wavelength? Hertz is a unit for frequency. Meter is a unit of wavelength. That's correct. Meter per second is for speed, and second is for time. So B is the correct option. Okay, question number 61. What is the number of wavefronts per second that pass through a fixed point? Basically, it's how we define frequency, right? So amplitude of the wave is the maximum displacement of a particle from its mean position. So this is not correct. B is the frequency of the wave, which is correct. Speed of the wave isn't defined by wavefronts per second. It is defined by obviously other attributes have to be accounted for. For D, the wavelength of the wave is the distance between two consecutive crescent troughs. So that is wrong as well. Okay, question number 62. The diagram shows a water wave passing through a gap in a harbor wall. The wavefronts curve round the wall and reach a small boat in the harbor. What is the name of this curving effect, and how does the gap be changed so that the wavefronts do not reach the boat? Okay, now we know that this phenomena is called diffraction. Okay, it's not refraction, refraction actually. And now what they want is that they don't need the wave fronts to reach the boats. This means that they want the spreading to be less. Okay, I've told you many times before as well, and I'm going to explain it one more time as well, that if you want the spreading to be less, then the gap should be larger, okay, or bigger, whatever. And if you want the spreading to be more, the gap should be smaller. Okay. So now what they want is that they want the wavefronts not to reach to the boat. So they want the spreading to be less. Okay. If the spreading has to be less, the gap should be larger. So if we look at these options, one option has make the gap slightly smaller and make the gap slightly bigger. So this is going to be our correct option. Okay. Spreading less, gap more. Spreading more, gap less. Okay. Question number 63. The diagram represents a water wave. Which row shows the amplitude and the wavelength of the wave? Okay. This is going to be approximately the mean position of the wave. So all of this is 2 meters. So one is going to be here and one is going to be here. So this is going to be 0. So amplitude of the wave basically is 1 meters. Okay, and the wavelength has to be between two consecutive crests or troughs. So it is between two. This is the wavelength for two waves. Okay, not for one single wave. So if this is for two waves, so for one waves 4 divided by 2 is going to be 2. So wavelength is going to be 2 meters and amplitude is going to be 1 meter. Amplitude is 1 meter and wavelength is 2. So answer is going to be A. Okay. Diagram shows 4 waves drawn to the same scale. Which statement is correct? The amplitude of wave P is the same as the amplitude of wave R. So if we look at this P and R, I think this is 0.5 and this is 0.5 as well. So this seems to be the correct option. Let's look at the other options as well. The amplitude of wave S is double the amplitude of Q. So S ka amplitude is 1 and it seems that Q ka amplitude is also 1. So this is not correct. It is not double. It's the same. The wavelength of Q is double the wavelength of P. So the wavelength of Q is almost 4 and the wavelength of P is also 4, so it is not double, it's just the same. The wavelength of S is the same as wavelength of Q. So wavelength of S is 2. 4 minus 2 is 2. So it's not the same as that of Q. So all other options are not correct and A is the correct option. Okay. Question number 65. Water waves may be used to demonstrate refraction by making them pass into water of different depths. Okay. Why does the water change direction as it passes into shallow water? Okay, we know that refraction has a principle that when the wave is in deep water, ठीक है, तो its speed is more, ठीक है, and when it's in shallow water, तो its speed is less, ठीक है. It's the change of speeds in different depths of liquids or water that diffraction takes place, ठीक है. So the frequency doesn't change, the speed of this changes, and some wavelength sometimes also changes as well. So they are asking about the why does water wave change direction as it passes. So the frequency of the wave changes? No, the frequency of the wave doesn't change in refraction. In fact, it doesn't change in the reflection, it doesn't change in diffraction as well. The frequency of the wave increases? No. The speed of the wave decreases? Yes, because it's going from deep water to shallow water. So deep water mein the speed is more and the shallow water mein it's less. So C is the correct option. ठीक हो क्या? Moving on to question number 66. A small boat in a harbor is protected from waves on the sea by harbor wall. Some waves can curve around the harbor walls and reach the boat. What is the name of this effect? Obviously, when the waves are going to pass through a gap or a barrier, they are going to diffract. So this principle is called diffraction. Okay. Question number 67. A boy throws a small stone into a pond. Waves spread out from where the stone hits the water and travel to the side of the pond. The boy notices that 8 waves reach the side of the pond in a time of 5 seconds. What is the frequency of the waves? Okay, now we know that frequency is uh, time period. So we know that there were 8 waves. Time for one wave now, so there were 8 waves and the time for that was 5. So 8 divided by 5 is going to give us 1.6 hertz, and C is going to be our correct option. Okay, question number 68. The diagram shows the surface of water in a ripple tank. The wave is traveling in the direction of the arrow towards the gap in a barrier. What happens to the wave as it passes through the gap? And what happens to the shape of the wave fronts after passing the gap? After the wave has passed through the barrier or the gap in the barrier, तो diffraction is going to happen. ठीक है, तो refraction तो हमने कट कर दिया. Shape after passing through the gap would be curved. Diffraction हुई है तो it's bending of the waves after they pass through a small hole. So it's going to be curved, not straight. ठीक है? That's the basic principle of diffraction. Question number 69. The diagram represents a wave. How many wavelengths are there between X and Y? Okay. So this is one wave. Okay. The distance between two consecutive crests, and then this is going to be the other wave now. So abhi this is almost half the distance. This is going to be 1.5 wave. Okay, abhi this portion is missing. Okay, so this is one wave and then another one, half of it. Okay, so C is the correct option for that. Question number 70. Visible light and gamma rays are both waves. How may they correctly be described? Okay, visible light is a longitudinal wave, gamma is a long. No, all of these are examples of transverse waves. So we will move to option D, which says that both of them are transverse waves. Okay, question number 71. A swimmer is sitting on a rock at the seashore looking at passing waves. He notices that 5 complete wavelengths pass him in 20 seconds. What is the frequency of the wave? Okay, frequency is when the time taken by one wave to pass through a certain point. So we actually have 5 complete wavelengths passing in 20 seconds. So this is going to be 0.25 hertz. Okay, 5154. Yes, 1/4 is 0.25. So A is going to be the correct option. Question number 72. The diagram shows plane waves reflected by a plane surface. Which line represents a wavefront? Okay. Now B is the wavelength. ठीक है? And D basically is the barrier कह लो, the surface कह लो through which the waves are reflected. ठीक है? So this is the direction of the wave. ठीक है? They've asked us about wavefront. So C is the only option that represents the wavefront. ठीक है? So C is our correct option. And moving on to question number 73, the diagram shows a water wave in a ripple tank. Which line represents a wavefront? So B represents the wavefront. I told you, okay, when we have these waves, so the imaginary line that connects the two crests, all the crests, two crests of the wave represents a wavefront. Okay, this is, I don't know what ये amplitude बन रहा है. Yes, this is the amplitude. C is the wavelength. So B is just the one that represents wavefront. Okay, question number 74. Which row shows the nature of light waves, sound waves, X-rays? Okay, light waves and X-rays are transverse waves. Sound wave is a longitudinal wave. So we will look for an option that says transverse, transverse, longitudinal. C is the correct option. I think we did this question before as well. Okay, question number 75. The diagram shows plane water waves passing through a narrow gap in the barrier. The waves spread out on the far side of the barrier. Which property of waves does this illustrate? This is an example of diffraction, so A is the correct option. Question number 76. What is the unit of wavelength? Unit of wavelength is meters. We did this question before as well. Question number 77. The diagram shows water waves passing through a gap in a harbor wall. The waves curve round the wall and reach a small boat in the harbor. What is the name of the curving effect and how can the gap be changed so that the waves are less likely to reach the boat? We did this question before as well. This is an example of diffraction. If you want the spreading to be less, so you should increase the gap in the barrier. Okay, both of these are inversely proportional to each other. So A is going to be the correct option. Question number 78. Which row correctly describes light waves and radio waves? Okay, light waves are transverse waves, radio waves are transverse waves as well because they both are a part of an electromagnetic spectrum. So D is the correct option. Question number 79. Radio waves are received at a house at the bottom of a hill. All of this is due to diffraction, the bending of the waves. Okay, and sound waves bend more than light waves. The waves reach the house because the hill has caused them to be diffracted. The bending of the waves. Okay, question number 80. Which of these waves is longitudinal? Okay, infra is transverse, radio is transverse, water is transverse, sound is an example of longitudinal wave. Question number 81. Water waves can be used to show reflection, refraction, and diffraction. For each of these, which row shows whether or not the speed of the water wave changes? Okay. In the reflection, the speed obviously does not change. Okay, so this is correct. Refraction may the speed changes. Obviously, when it refraction is the movement of water from a deep to shallow or shallow to deep, and refraction happens because of the difference in the speed in the two depths. Okay, so this is not correct. Okay, if we move to B, reflection may no change of speed happens. This is correct. Refraction may there is a change of speed, and diffraction may also there is no change of speed. So B is going to be our correct option. We've reached our correct option. Okay. Okay. Question number 82. A navigation buoy floating on the sea oscillates up and down as a wave passes. In exactly 2 minutes, 6 complete wavelengths pass the buoy. What is the frequency of the wave? Okay, frequency का formula is 1 over t. तो 6 complete wavelengths pass. in a time of 2 minutes to 2 minutes has to be converted into seconds. So this is going to give us an answer of 0.05 hertz, and A is the correct option for that. Question number 83. A vertical stick is dipped up and down in water at P. In 2 seconds, 3 wave crests are produced on the surface of the water. Okay, which statement is correct? Distance x is the amplitude of the wave. No, x is not the amplitude of the wave. It's basically the wavelength of the wave. Distance y is the wavelength of the waves. Why may there are 2, 3 covered up to? No, that's not correct. Each circle represents a wavefront. Yes, this is correct. C, each circle is a wavefront. The frequency of the wave is 3 hertz. No, this is also not correct. Question number 84. The diagram shows a wave which labeled distance is the wavelength. Okay, wavelength would be between 2 consecutive crests or troughs. So if we draw the line over here, so from here to here, yes, C is the wavelength, A is the amplitude, B is half the wavelength maybe, and D is also nothing. So C is correct. Question number 85. The diagram shows water waves which move more slowly after passing into shallow water at the broken line. Which diagram shows what happens to the waves? Acha, in A there is nothing happens, so it is not correct. In B the speed has actually shown to increase in slow water, which is not correct. Yahan pe the speed would be more and here the speed would be less. So it is going to lag behind a bit, not move forward. So this is C seems to be the correct option. If you see that they are lagging behind a bit, okay, na? This is going to be it. So C is the correct option. D में the wavelength has changed, but the change of speed is not shown. So this D is not correct. Oh, sorry. Question number 86. Sound waves travel from point X to point Y. Okay, which diagram represents the movement of air molecules caused by the sound waves in the region between X and Y? Okay, they are sound waves, so they are going to be longitudinal waves. Oh, I've written the spellings wrong. Longitudinal waves, and the direction of vibration of the longitudinal waves is along the direction of the wave. So if the direction is of the wave is in this way, so they would be traveling in this way, and if the wave is traveling in this way, so they would be traveling like this. So B is the correct option. This one is for transverse, and these also are not correct. Question number 87. The diagram shows example of wave motion. This is a ripple tank and these are waves on water. Okay. And this is sound waves. Okay. Which are longitudinal waves? So water waves are example of transverse waves. Okay. And this up and down movement, the direction of the vibration being perpendicular to the direction of the movement of the wave. This is also phenomena experienced in transverse wave. These are sound waves, which are longitudinal waves, and these are longitudinal waves as well, which show the direction of the vibration to be parallel to the movement of the wave, either this ways or this ways as well. So the longitudinal waves would be 2 and 4. So D is our correct option, and this brings us to the end of the topic, general properties of waves, which had questions related to sound waves, water waves, phenomena that the waves face, and the properties of the waves. So we've done this, and inshallah see you in another video very soon. Up till then, take care of yourselves, and Allah Hafiz.